Part A. Let's go right into using that shortcut now. So since we have the natural log of a function, the shortcut says it's the derivative of the function over the function itself. What's the derivative of the function? 10x minus 8. Good. Over the function itself, 5x squared minus 8x plus 1. Okay. Part B. What do we have to use first? What major named rule do we have to use first? The product rule. Because there is really a times in here. So your first is x squared, and your second is the natural log of x squared. So if you would, please try the product rule. Alright, so it's the first, x squared, times the derivative of the second. What is the derivative of natural log of x squared? Don't clean it up just yet. Just leave it alone. 2x over x squared. Very good. So the derivative of the argument over the argument. Is that okay with everyone? What operation comes next? Plus the second natural log of x squared times the derivative of the first, 2x. Awesome. So 2x over x squared simplifies as what? 2 over x. So what's x squared times 2 over x? Because we have x squared here. We have 2 over x here. No. 2x. Right. Because you have 2 up top and 1 downstairs. The second guy, I'm just going to put that 2x first. Natural log of x squared. As far as simplifying, that's fine for me. If you wanted to, you can pull out a 2x, and you're left with 1 plus the natural log of x squared. It doesn't look any better. Find the derivatives. Apparently there's more than one, they're just hidden. F of x is log base 7 of the cube root of 5x minus 12. One trick we've been learning is, if you simplify the main function, you may have less work to do. So like on your last worksheet, you could possibly avoid the quotient rule, which is a hassle, and then write it as a product instead, which isn't that bad. Okay? So this guy, this function can be simplified. If we don't simplify it, then we have to do the chain rule twice. Because we have a function inside of a function inside of a function. It's a 3-tiered function fiasco. So it's better if we simplify first. So how can we rewrite this so that it's simplified? Yeah, a cube root is a 1/3 power. And now that your argument is to a power, what could you do with that power? According to the power rule for logarithms. So let's just say its name got called in The Price is Right. Yeah. 1/3 log base 7 of 5x minus 12. So we just eliminated one of the composition of functions. So now we only have to do the chain rule once, which is a lot nicer. So since that's a constant times a function, what happens to that 1/3? Stays. Yes. Huh? Yeah, there you go. So the derivative, the 1/3 sticks right there. Since we have a log of a function, we'll be using our second rule here. So this will be 1/3 times what? 1 over natural log of 7 times. Got it. So again, you can write that as one big fraction by multiplying across the numerator and denominator. Just please be careful. But that's the thing, it's not a power rule. From here to here is your power rule for logs. So this was not calculus, this was just algebra. If I had x to the 1/3 and took its derivative, yes, you'd have 1/3 x to the negative 2/3. But that's the process of taking the derivative, which we avoided by cleaning up the function in the first place. If we had not done it, now you asked for it. If we kept it like this, the derivative would be 1 over the natural log of 7 times the derivative of the function, so that'd be 1/3. Leave that alone. Take 1 off. This should be 2/3. Times the derivative of the inside over the function itself. So if we didn't put that 1/3 in front, this is what we'd have to write. Which do you prefer? Right. Is that okay? Look at it. It's like train wreck. If 2 trains filled with unicorns clashed together, that's what it would be. I don't know how unicorns got on the train. We don't know. That's okay.